When you're talking about biofuel quality, I've ranked this into first, second, and third. In third place is the marine gas oil. With the ISO 8217 specification, you have a minimum viscosity of 2 centistoke at 40 degrees Celsius. You have an ash content that could be up to 0.01% in marine gas oil, and a minimum cetane index, or we refer to cetane number when we talk about biofuels, of 40. When we're looking at FAME, a biodiesel, the B100, it has no carbon residue in the specification. There's no metal and contaminations because there's a limit for that. The sulfur content is very low, but with FAME, you do get the lubricity of the product. So even if the sulfur is low, you do have good lubricity in the fuel. The oxidation stability. Now, a lot of people think that FAME cannot be stored over a longer period of time, but I mentioned it could be stored up to 2 years now because the specification has changed. It's stricter rules on oxidation stability. So it's been improved since the last specification. So there is better storage condition shelf life than before. The cetane number is also higher than with marine gas oil, with a minimum requirement of 41 in the cetane number compared to 40 for MGO. But the nice thing about FAME that the chief engineers that I talked to is that the viscosity at 40 degrees is minimum 3.5 centistoke. So it's much higher than the 2 centistokes that you get with gas oil. So that is a really nice thing. And that's why we ranked FAME as it is when it's being produced and being delivered is a better quality than marine gas oil. But what tops it is HVO, renewable diesel, meeting the 15940 specification. It is an automotive fuel. It's a paraffinic fuel with excellent cold flow properties. And you may say to yourself, how can that be? How can it be paraffinic but still be excellent cold flow properties? Well, during that hydro treatment process, you also go through something called isomerization process. And that makes the chemical composition stay the same, but the structure changes. So you get a very straight carbon chain, which is paraffinic, but the carbon length is reduced, you can say in general, meaning that the density is lower, like you saw, around 780, but then you get excellent cold flow properties with that. So it is too good of a fuel for the marine industry because it is an automotive fuel, but we see that some prefer it because it is a good cold flow properties. But with this technical presentation, maybe you'll get some insight into FAME and that you can say that, you know, FAME is just as good for us to use and we don't need to use HVO.
Yeah, and maybe to add to that, you see on the right side of the slide also the greenhouse gas savings or emission savings and the production cost for different products which are derived from used cooking oil. So we want to show that actually to put it a bit more into the commercial perspective. So products which are biodiesel, UCAMI biodiesel, which is derived from used cooking oil, which is, yeah, let's say good enough for a car engine, as well as the HVO derived from used cooking oil. You can see that the greenhouse gas emission savings are better actually for a biodiesel from used cooking oil compared to an HVO of used cooking oil. And the reason is that the production of hydrotreated vegetable oils or HVO, renewable diesel, is much more energy intense. And also you see here more costly in terms of the production cost than the production of biodiesel. And this is important because if you use the same biofuel or the same feedstock eventually to produce different product streams, also for different industries, it shows that biodiesel is the best in terms of, or better, let's say, choice in terms of costs and also in terms of greenhouse gas emission savings. We're showing this here also because you can see that renewable diesel, the HVO, is more for the road transport and certain marine applications eventually, depending on the cold properties. But used cooking oil, co-processed product, co-processed marine gas oil is, for example, a product which comes from the refinery, from a crude oil refinery, where used cooking oil as a sustainable feedstock has been used. But you see also here the greenhouse gas emission savings are lower compared to a biodiesel, and the production costs are higher. HEFA, this stands for hydrotreated esterified fatty acids, which is basically the process of putting a biodiesel into an HVO plant. So this is the production of aviation fuel, sustainable aviation fuel. So you can see that basically used cooking oil as a feedstock is used by different industries, not only by the marine industry, but also the road transport sector and also aviation. And maybe going back to that question we got earlier, is there enough used cooking oil available? Just to get back to that, because it is used by other industries as well to decarbonize, there is definitely a need to verify and diversify the feedstock portfolio for the marine sector, to look into alternative feedstocks, sustainable feedstocks that can be used for marine, which are not competing with the road transport, which are not competing with aviation. And the most recently added cover crops, damaged crops, which are categorized as second or third generation biofuels as advanced, I think can help here to have a broader pool, a broader portfolio of products, of feedstocks that can be used by all industries. So that's also an effort we are making as a group, and Dan Bunkering is making, to identify alternative feedstocks that are meeting the sustainability criteria of IMO and FuelEU Maritime, but they are less competing with the road and aviation sector, so that there will be enough product available in the future for the marine sector.
Manja, just on that, there's a comment. Are there any concerns about blending Gen 1 and Gen 2 biodiesel?
Well, under FuelEU Maritime, first generation biofuels or feedstocks are not accepted. They are considered as fossil, or even worse than fossil in terms of their emissions. So if you're blending those products, then it can be a problem, because you're not meeting the FuelEU Maritime regulation. Under IMO requires the 65% in GHG emission reduction of a fuel. It could be allowed to use certain first generation biofuels. There's also the concept of a mass balancing, so that physically you can have maybe a different molecule than what you are sold to on the documents or on the paper. What is most relevant, or what is really important for the shipping company, is that the proof of sustainability, the POS, is containing the right feedstocks that are eligible and sustainable under the IMO and FuelEU Maritime requirements. So when the shipping industry or a shipping client is claiming their greenhouse gas emission savings, the proof of sustainability needs to be handed over to the verifier, and this needs to state the correct feedstock and, of course, the correct amount that is claimed by this shipping operator or ship owner.